Hi folks, yesterday we were talking about transforming functions. So some of you didn't stay in class, you decided to take the quiz, which was totally fine. So I would go back and watch the recording from yesterday before you watch this video, because this is kind of picking up where we left off in class yesterday. So if you missed class yesterday for any reason, go ahead and watch the recording first and then you can come back to this. So yesterday in class we left off with talking about what happens to the intercepts when we do these different transformations. And we said that when you are doing a horizontal stretch or a compression, that means you're pulling it away from the y-axis or pushing it closer to the y-axis, but your intercept on the y-axis doesn't change. Excuse me, it's only your x-intercepts that change. Okay, with vertical stretches or compressions, you're stretching it up or down, so you're pulling it away from the x or pushing it down towards the x. So your y-intercepts are the ones that change, but your x-intercepts stay the same. So with vertical, the y changes. With horizontal, the x changes. Okay, so let's then talk about reflections. Okay, you always change the opposite intercept of the axis you are reflecting over. So if you reflect across the y-axis, you change the x-intercepts. If you reflect across the x-axis, you change the y-intercepts. And they end up just getting negated. So you change the sign. If it was negative, it becomes positive. If it was positive, it becomes negative. And we talked about this particular problem right at the end of class yesterday. And we're given this function f of x equals negative 2x minus 4, this function right here, and then the function g of x took the function f of x and did a horizontal stretch of 2. And you might say, well, wait a minute, there's a 1/2 there. But remember, when you're dealing with horizontal stretches, this is the inverse, right, or the reciprocal of what b would be, right, because this is 1 over b for horizontal, which means that b is equal to 2. That tells us that we're doing a horizontal stretch because that number is greater than 1. The reason I know it's horizontal is because it's in the parentheses with x. It's not out in front of the function. Okay, so the first thing we did was we found the intercepts, the x and the y intercepts of the function f of x. To find the y-intercept, you just set x equal to 0. To find the x-intercept, you set y equal to 0. So this is your y-intercept, and this is your x-intercept. Okay, so that's where you're crossing the axes. Now, we just said that when you are doing a horizontal stretch or compression, that your y-intercept doesn't change. Okay, so my y-intercept stays at negative 4, but my x-intercept changes. Because I did a horizontal stretch by a factor of 2, I multiply that x-intercept by 2, and so now my x-intercept is negative 4. And you can see in the picture, the blue line was our starting line. After we do a horizontal stretch, it's getting pulled away from that y-axis, but notice my intercept didn't change. Okay? Let's talk about another problem. We have this problem, f of x is equal to x squared minus 1. When you look at that, that's a parabola, and it's graphed over here on the right. It's a parabola that goes through negative 1 on the y-axis. So your y-intercept is at negative 1. And over here, g of x is taking that function. I'm negating the x, right? I'm negating the x. That means I'm reflecting it over the y-axis. When you negate the x, you're reflecting over the y. So all of the values over here get shifted over to here, and then all the values here get shifted over to here because it's reflecting them across the y-axis. So your picture, your new picture that you get, looks exactly the same as the original image that you had because you're just flipping it across the y-axis. So notice my y-intercept didn't change. It stayed right where it was. Okay. Let's look at another example. This one is saying to find, first identify the x and y intercepts of the function f of x, and then perform this new transformation. So let's first look at the function f of x and figure out what our x and y intercepts are. To find our y-intercept, we're going to set x equal to 0, so that's what we did down here. When we set x equal to 0, we end up with y is equal to 4. That's our y-intercept. Then to find the x-intercept, we just set x equal to 0 and solve that, and we get x is -6. Okay, so those are our two intercepts. And now we're going to then go ahead and do this transformation. I'm negating the y. I'm negating the whole function, which is the same as negating y, which is the same as reflecting over the x-axis. Okay, so when I reflect across the x-axis, I end up, and it says right here, we start off with our intercepts of y is 4 and x is -6. When I reflect across the x-axis, I'm flipping it over the x-axis. So this was my original line. When I flip it over the x-axis, it ends up down here. So this is my new y-intercept, but notice my x-intercept didn't change. Okay, but my y-intercept got negated because I reflected over the x-axis. Okay. Let's look at another one. In this problem, again, we have a parabola, x squared minus 9, so our y-intercept is down here at -9. And we have this 1/3 out in front of the function. That tells us that we're doing a vertical stretch or compression, but because 1/3 is less than 1, it's a vertical compression. Okay? Which means that, and it says down here, that the x-intercept will be ±3, but the y-intercept will now be at -3. So what happened? I did a vertical stretch or compression, which means my y values are changing, but my x values don't change. Okay, when you do a vertical stretch or compression, you change the y-intercept, but not the x, because you're stretching it up or down, so the y changes. Okay? To figure out what it changes to, all you're doing is taking that compression factor and multiplying it by that y-intercept, so 1/3 times -9 gives you that -3, and that is your new y-intercept. Your x-intercepts don't change, so that's why you end up with this new parabola. Remember that when you are doing horizontal stretch or compression, you have to take the reciprocal of what is in the equation, okay? And we just talked about that when we had the 1/2 and the 2. That's all it means. We just have to make sure that we take the reciprocal. Okay, so we have this function f of x is equal to 1/3 x minus 2 squared. Okay, and then we have this function g of x, which is 2 times f of x and then -3. Okay, so this 2 times f of x means I'm doing a vertical stretch of 2. When I tack this -3 on the end, that means I'm doing a vertical shift down. Okay, so that's shifting it down, but this 2 is a vertical stretch. So let's go ahead and start by just graphing f of x. When we graph it, we see that we have a y-intercept of 0, 4/3, right? And to find the y-intercept, you would just plug 0 in for x and solve it, so we get 4/3. And to find the x-intercept, we would just plug in 0 for y and solve that, and we get that x is 2. So those are our two intercepts. Now, from there, we have to analyze the transformations separately, because remember, we had a vertical stretch of 2 and then a shift down of 3. Okay, so let's do them separately. The first thing that we're doing is the vertical stretch. Okay, after we do the vertical stretch, remember that the x-intercept doesn't change with the vertical stretch, but the y-intercept does. So all I'm doing is multiplying that y-intercept by my vertical stretch factor, which is 2, and that comes out to be 8/3. Okay? So my y-intercept doesn't change, but my x-intercept doesn't change, but my new y-intercept, this is my y-intercept, is now at 8/3 instead of 4/3. Okay? The second thing that we're doing is shifting everything down 3 units. So if we just take our intercepted points, right, where our x-intercept is and our new y-intercept is, and I shift those down accordingly, I'm shifting this point down 3 units. So the blue graph here is our original one, red one is our new one. So I shift it down 3 units, and I shift my other points down 3 units. So I was at 0, 8/3. I'm now at 0, -1/3, because I subtracted 3 from that. Okay, so 8/3 minus 3, that's the same as doing 8/3 minus 9/3, which gives me -1/3. And so I'm shifted down here at -1/3. Here's another example. So a couple of things that are going on here. We have this exponential function 2 to the x minus 4. So that's our blue graph right here. We are doing this transformation to it. There's 2 things here. We're doing a vertical compression of 1/2, and then that negative means we're doing a reflection. So find your 2 intercepts first. Okay, my intercepts are 0, -3, and 2, 0. Then go ahead and do the transformations. The first one is the vertical compression, which means we change the y-intercept. We multiply the y-intercept by 1/2. Okay, multiply the y-intercept by 1/2. So that would take us to -3/2. Our x-intercept doesn't change. Okay, so that's where we end up with 2, 0. The x-intercept stays the same, but our y-intercept changed to 3/2. Okay, then we also had a reflection. This negative sign here means we were reflecting over the y-axis. So all I did was flipped it over with my new y-intercept. Okay. Just a quick little example problem on with a piecewise function. And actually, I'm going to hold off on this just because I'm running out of time in my video here. So we're going to hold off on this for now, and we're just going to keep things as they are. So that should help you out, hopefully, between the recording from yesterday's class and this video will help you with completing today's assignment. Okay, everybody, have a great day. We'll catch you next time. Bye-bye.